Okay, I want to have a quick, somewhat informal review of what our team built for a internal network to code Nautobot hackathon to kind of highlight some of the capabilities and new features introduced with the Nautobot 1.0 release. And so our team built a plugin based on what I've termed application dictionary, and I have blogged about this. And if you are interested to hear me ramble on a bit longer, you could check out Packet Pushers Podcast 573. But fundamentally, the idea here is to change the way in which we deploy firewall rules from that traditional 5-tuple-centric view to application definitions and relationships between those application definitions. Meaning, if I have these two applications, I define them as in their own right, and then I describe how they're related to each other, right? And so I could say that this application connects to this application, or so forth, right? And in here you can kind of see various different application dependency definitions, those relationships between applications. And so by understanding what defines an application, from an IP protocol level, you can start to build the relationships and the actual 5 tuples between them. So our team for the Q1 hackathon built a plugin around the application just to highlight our team. It was composed of John Anderson, Brian Culver, Jeff Kayla, Christian Carbonaro, myself, Ken Salenza, and Chip Nielsen. Okay, so let's get into the nitty-gritty details of what we built here. So in the background here, I am I am refreshing, and I've just built, and I'm working this a bit backwards. So I'm going to start with the kind of 5-tuple view, show how automation is kicking off and deploying these rules, and then work backwards through the data model to show how this traditional 5-tuple looking rule set is defined by the data instead of just statically define each one of these row elements, as most of us probably have done with traditional firewall rules. So first I want to start with this clean parallel firewall. No rules, only pre-rules, which we'll see will not be affected. We will just deploy we will deploy the new rules based on this firewall rule set. So first, we'll go to Jobs, Configure Security Rule, choose our firewall, and deploy. And so the first kind of feature to kind of highlight here is the ability to package jobs with your plugin. So no longer do you have to have no longer is the only mechanism to kind of bring these custom reports and custom scripts is putting them on the actual file system, organic code on the actual file system. You can package it with the code itself so that you can distribute it. So let me see if I can catch this live, as this is configurations. It may already be done, may already have deployed all the configurations, but you can see now that the configurations that are being deployed are roughly the same as basically the same as what's being built here in this view, right? For this firewall view. So let us check, make sure, okay, and we'll go, and it's probably committing the code committing the configuration to the panel as we speak, and we get the status that this job has completed in just under a minute, and deploy the configurations as expected. So great, we can deploy configurations, but that's not the point of application dictionary. This is kind of the opposite of this rule-centric view of configurations, which is very difficult often for the average requester to kind of put in and understand what their IPs are, what the destination IPs are, what the destination ports are, etc., etc. So we will go through these various different components here. Again, those 4 components. There are 4 components that make up the application dictionary, the definition of the application, the dependencies between them, the relationships, the component of it, and the service, which is tied to the component. And to kind of highlight that a little bit better, let's review this simple diagram that we have here. And you'll notice a few things. One is that you can have, it's very, there's multiple sets of tiering, and in each level of tiering you can have multiples as well. As an example, you can have multiple servers, multiple components, multiple services, multiple protocols within a service, right? And if you notice something else here, you have the banner here twice, and this is just to kind of represent the source destination that we're kind of traditionally, as security engineers, reviewing and understanding. Or this is how we, generally speaking, look at security policies, right? So you'll have a source listed multiple times to all of its destinations, and vice versa. You might see the reverse as well. Now, so let's kind of review each one of these buckets. So at the highest level, you have an application, which is a logical construct. Beneath that, you have components. So multiple components can be assigned to the same application. And then one or multiple services could technically be applied to components. Now, components can have multiple servers as well. And then again, there's an implied relationship between the source and destination. Destination, as depicted here, and explicitly stated, as we'll show throughout the application. So what we're going to do here is go through various different use cases, change data in various different ways, and show that how that reflects in the configuration that's deployed to the firewall. So let's dig into the Active Directory application, and you'll see here it has a service LDAP. That server has a service that exposes LDAP, right? So the first use case we're going to go through is to add an additional server. So we'll start by attempting to add NYC server 11. And lo and behold, we cannot add that. The reason is that the device role is not of what we intend it to be, which is another kind of feature of Nautobot, which is to provide truly endless capabilities to enforce whatever business logic an organization may have via programmatic, not only regex kind of based enforcement or some kind of string-based enforcements, which is certainly valuable, but to sit there and say whatever arbitrary enforcement that would make sense for a given use case. So, in order to address that, we need to change the role. And we'll have to change it to application server. We will save that. And we will try again. And sure enough, in this contrived example, it suddenly works, right? And now we can add to it. And what we see is in our application definition, we see that our component has multiple servers. Those servers get exposed. The service can actually reach back and understand that there's an additional server now applied with an additional IP address of 20.101. Now, if we go to the firewall rule set, if we'll notice, as example in this second row, as I refresh to get the latest information exposed by that, we see that in fact this IP address is now applied any place in which the Active Directory is a source or a destination, right? Because it's part of that service, and it will be it's part of that component, and thus it will be exposed via that firewall rule set. Now, how are we defining those relationships? In here, we have our dependencies, which map our sources and destinations. So you can see that everything uses Active Directory and the LDAP services associated with it, and you can see how it is defined. Okay, so next what we're going to do is we're going to build a new application and then build the dependencies for that application. So let's start by going back to our applications. We will add an application, and we will call it Banner, which is a student information system. And we will assign the owner to be NTC. Okay, great. So now we have this new application Banner, but it has no components or services applied to them. So we will do everything near in line here, and so we will add a component here for let's call it Banner app tier. And we will give it the server 6, which it will be installed on. Okay, now you'll notice we are in the component, and the component has no service. So let us add the service to the component, and we will call the service Tomcat, and use a standard port of 8000 and a justification. Okay, and there's a lot of data points here. You notice the justification. We kind of use confidentiality. The important thing I'll pause here to note is really the end state is to build the configuration to actually deploy it, or one of the primary use cases, I should say, is to deploy the firewall rule configurations. However, it's certainly not the only one. And in doing things like applying owners, justification, confidentiality, having these pieces of metadata, and there's many more pieces of metadata to create, you can determine your security posture. So, as an example, you can understand what the level of confidentiality is, and then start investigating things like what is the security posture for data in flight and data at rest. For data at flight, it's perhaps easier to understand from a centralized system. For data at rest, of course, you would have to understand what happens to that data. But nonetheless, you can start aggregating the metadata and associating that back to specific owners of the application. Okay, so with that said, let's go and create that, and let's go back to the application definition. We see that it is in the list of applications, and now we have kind of built out this this application, but we don't have any dependencies yet. So if we go to our dependency, let us create a dependency towards from Banner to Active Directory. Great. Okay. So now with that, as we refresh this, we should start seeing the Banner application start showing up. Okay, and lo and behold, we do in fact see the Banner application show up. And let us go and add a another dependency here. We'll say that banner actually also speaks to Postgres. And we'll create that application, or that application dependency. And we see one banner, definition, application definition, and as we refresh, we see another. Okay, so another interesting part to understand is in the back end, what's actually happening here is there is, in order to build, before we truly understand how this application works, everything is being built with GraphQL queries. At a later date, we may go back and build a specific ORM query to be optimized exactly for how this is used. But for now, the development time is amazing, to be honest, how quickly you can use GraphQL to build your dependency, your entire data structure in your dependency tree. And what it looks like is something like this. And hopefully this works, because I have not tested it out of late. Perfect, it does. And this is, roughly speaking, what we needed to build. And maybe through a little bit of trial and error, we were able to kind of build this out fairly quickly. And we have, as you look at this, we have essentially what the source data that we use to create the firewall rules. All right, awesome. So we will first, I want to take pause for a second and just go to the UML diagram to describe some of this and how the relationships are created. So one component you may have seen me go through and not touch within the plugin is the mapping. And so we have an outside zone mapping and an inside zone mapping. And so the outside zone mapping is, how do you know if you appropriately tag all of your prefixes and they are all within an inside zone map, how do you know when the packet is going to leave the firewall externally, because it's not on one of the southbound inside zone interfaces? Where does it go, right? And so there's many different designs, and for the hackathon we have this kind of simple in and out based firewall. Obviously, with more complex use cases, there will have to be more complex, or the more complexity here, rather than just simple inside and outside. But nonetheless, we stated that the zone to leave the environment is simply called external for a given firewall. And then for inside zones, we assigned actual prefixes to the inside zone of a given firewall. Right? So you can have n number of inside zone firewalls, and you can have n number of prefixes within there. And we can see how we can tie in various different subnets that are required. Now, how this relates back to the UML diagram is because the application component ultimately is related to the device and an IP address, and an IP address kind of assigned there. That IP address is known. Then on the zone mapping, right? There is there is a mapping to a prefix. I believe this UML diagram is lacking one more south zone here, but just presume it was here. The fundamental component here is that we know what prefix there is and what zone that maps to. We can now link that to the device's IP address. And so since we know IP to zone, we can predict, or I shouldn't say predict, we know which zone it should be on. Now, this does imply that you have to tag all of your prefixes with zones. Okay. So, with that being said, we provided at the end of that, because we can map from application to zone, we can now rebuild this entire firewall 5-tuple rule set. Okay, great. And let us go back and run the job one last time with the new rule set. And ideally, we can watch this update near live. There we go. We start seeing everything starting to populate. We see the 101 IP address show up and the banner firewall rules added as well. Awesome. So I love this. I absolutely think this is the way to think about firewall rules in general. Hopefully you do as well. And there are a tremendous amount of complexity that is involved. And just to list off, bear with me 1 second as I grab some of our notes of ideas that we simply would not have time to get to, and complexities that we've avoided in our initial simple use case. But as we move into the modern world, one of the things that is happening is there's more often than not simply an IP definition that you can actually even tie to, right? So, as an example, there's some fundamental flaws to this idea that you can just simply map it to an external entity to an IP address. Perhaps it's in Palo terms, an EDL, an external dynamic list. Perhaps it's a tag on an NSX controller. Perhaps it's a container and a service kind of exposed via container. Perhaps it's an FQDN, right? So each one of these things introduces different levels of complexity that can be solved, but it's not simple, right? So what we did in a one-day hackathon, we certainly did not get to it. Other things that we start getting into are things like beyond just IP protocol. Palo Alto has App ID. There's URL parsing. There's a tremendous amount of other mechanisms in which to describe a destination rather than traditional port and protocol nowadays. There's a lot of other metadata that we need cover. Like is encrypted. Is there authenticate? Is the entity authenticated? Where is the enforcement going to take place, right? So we made some presumptions here in the limited scope hackathon to not to just have one single firewall. There's actually technically two, but we just kind of demonstrated just showing one firewall. But you can have different enforcement places for different entities. So as an example, you could use firewall D or IP tables on a server. So do you need to actually duplicate those firewall policies, or do you just trust that end policy? Is it deployed? Is it secured in security groups in your AWS cloud infrastructure? You may not need to affect the firewall, right? There's various levels of application tiering. We have a very high-level buckets of simply application component services, but there would need to be a ton of other kind of in the real world. There's a lot of other tiering that would need to be used. Things from application groupings, such as finance and so forth, and how to properly break down an application between various different pieces. And then maybe one of the last things is the approval process. And if we go back to the blog, kind of talk about that here. And if you think about things like LDAP, Active Directory, right? So that's the use case we use. That application owner provides a service for the rest, more than likely provides a service for the rest of the company. Anyone can subscribe to it, right? And so they do not want to fulfill every single request that comes through. Whereas some financial application, the application owner may actually want to have that request. And so how do you signal that this application can't just, not everyone can just get access to it. They actually has to go to the application owners as well as the security reviewers, right? So we're kind of trying to pick that where the security reviewers and the application owners may optionally gatekeep the access to their application. A long way around of saying there is a lot of complexity not shown here, but nonetheless, I'm still super proud of what the team produced, and kind of showing the power of the entire platform. So hopefully you enjoyed that. If you did, you know where to reach me. I'm probably most of the time on Slack, on Network to Code Slack. I'm It Depends Net on Twitter. My GitHub is It Depends Networks, and blogging at Network to Code, blog.networktocode.com, as we see here in this application dictionary post. So, thanks again. Hope you enjoyed.